has anyone seen Castaway? Remember when Tom Hanks was in the cave and he was marking things on the wall? It's exactly what I thought of when
Machine
you were
learning.
talking about that.
Exactly. He's doing machine learning.
Channeling my 2,000-year-old man. From cave walls to neural nets, this is the story of machine learning. You're listening to the AI Thought Leader series on the Helical Brew podcast, where we blend science, culture, and innovation, one episode at a time. Welcome, everybody, to the Helical Brew, another episode on tap. This is going to be our third in our segments of focusing on AI and talking with AI thought leaders. And I'm super excited today that we are joined with, and I think this is before I say his name, this is an opportunity for a deeper dive, because we are going to talk with an AI architect today. Tony, Reina, welcome. We're glad to have you with us, and thanks for joining the Helical Brew.
Thanks so much, Mike. Appreciate it. Thanks, everybody.
Yeah.
Great to be here.
Yes. We're going to continue our segments, and I think we may have another, 4 total, possibly 5 or 6. Who knows how far we go, Sura, right? In the AI series, right? Who knows? We could break records.
Depends on interest.
But I feel like it's super interesting. And,
Yeah, but we got to get those clicks, to tell us we need more guests.
We're going to start using AI to suggest other AI experts.
Which is a good reminder. I think the team is reminding me, to remind you to like, subscribe, and ring that bell, hit that like button, smash it, and subscribe to the Helical Brew. So you'll get this episode along with more episodes and be able to watch all of our previous episodes as well, and check out some of Sura's great shorts that she's been doing on our YouTube channel. So welcome, Tony. And yeah, the way I like to start, just to give you some background, we've titled this episode "The Machine Learning Blueprint: AI Architecture with Tony Reina." And again, we're going to extrapolate from that and kind of go through, what got you to arrive where you're at today. What are you passionate about? But just give us a little background. Tell us about yourself.
Yeah, sure. So Tony Reina, I am married 29 years, 2 kids, one's in college and the other one's just finishing high school. So I have we were talking before about kind of the circuitous paths and things. So I did a background in neuroscience and did a postdoc in basically what was before it was called like brain-computer interfaces. It was things like that. And then I ended up, my wife's a psychiatrist in the Navy. So I ended up taking off few years to be the stay-at-home dad. It ended up starting to be, it was supposed to be only 3-4 years. It ended up being 12, but eventually went back and my wife retired and, slapped hands and tag teamed out. And I went back to start at Intel. And I ended up coming in at a very fortuitous time because the AI this latest wave just started to hit. And so I was only a few years behind because the technology was, the newer technology was so new. Went from there, I was the chief AI architect for health and life sciences there because of my healthcare background. And then moved on to a biotech company that Sura and I worked together called Rodziewicz. We were doing cell therapy and gene therapy. And now head of machine learning at a small, we're sort of still stealthy biotech startup here in San Diego, California, called Exthymic, still doing cell therapy.
Oh, very cool. Yeah, Intel is a company I've noticed over the years that they, we know them for chips. We know them for making the chips that power a lot of the computers we've used. My first technically the first computer we had was a Motorola 68,000 Apple way back in the 80s. But the computer I went to college with was Intel, and everybody I knew had that. And, right around the time I was in college, early 90s, I saw them start to go into particular vertical markets like life sciences or, even the 3D camera approach, right? Having the ability to do low cost 3D cameras, even bus architecture. I think Intel was the one that started the Thunderbolt development that eventually became the USB-C based Thunderbolt that we know today. And they've always had these kind of side projects. Some do better than others. They even got into, I believe, cellular modems at one point.
They dabbled, yeah.
Yep. They dabbled, right? It's like sometimes, and that makes me think of Qualcomm, right? They're the big giant in San Diego.
They're here,
and it's like even a giant can't take a bigger giant can't take out another giant when they've got so much tacit knowledge. And so, what was it? I mean, in terms of when you were there at Intel, was it we're kind of building it from the ground up? Did you join it at that time when they were kind of going to the life science sector and health?
So they had been doing the health sciences for quite a
Okay.
time. The one thing that was, I guess, surprising to me when I kind of started there was I hadn't really thought of it before, but like all of the medical devices run some sort of compute, and it's often they have a CPU in it, and the CPU is often an Intel processor that's in it. Nowadays, they also will have like NVIDIA GPUs, or they'll have AMDs, or they'll have ASICs or FPGAs or something like that. But there's ultimately, even if it's an MRI or an X-ray or something very simple, there's a computer in there, and so that's why Intel has been there for basically since the beginning, just helping out with that compute.
Okay. Yeah. Facilitating. They see what customers are doing. They're like,
Exactly.
we could
Yeah.
help you. We might be able to
exactly.
tweak things. Kind of what I sort of leads me to NVIDIA now that I think about it. You know, it's like NVIDIA is like graphics cards. It's like, well, you know, we use graphics cards to do Bitcoin,
Exactly. Yeah.
you know, mining or all these other things. Like, well, why not use it as an AI engine
Yeah.
as well?
Absolutely.
So very interesting. And were you overlapped at the Sura, you and Tony at the same time?
Yeah,
The whole
Tony,
duration? Okay.
Yeah.
and he's very humble, I have to say. Like,
Okay.
he'll be at meetings and he'll take in all these ideas about how we want to visualize data or try to like build dashboards that are actually like allowing us to do some real analysis on the massive amounts of data coming in. Like, yeah, I think I can make something. And then he'll come out like in no time at all with this amazing interface. And you're just like, how did you do this with all these
That's
images
awesome.
coming out of this machine? Very humble.
Thanks so much. Yeah, actually, I think Sura took my desk, my original desk, when she came on. So I think you came on like maybe not
In
even
the
a
first
month
building or the
after,
second
in
building?
that first
Ah.
building, because you were sitting next to Andrew, and Andrew was sitting Andrew was there like the week before me. Then I got in, and so I was sitting in that desk to the left of Andrew, and then we ended up getting moved upstairs, and you took that desk. So the kitchen was right behind. I don't know how many times you had to do this, but like people were coming by to get snacks from the kitchen, and I'd have to like push my chair in because it was too far out, and so it was not like the nicest
Blocking
desk
the
in the
kitchen.
world. You're blocking the kitchen, Tony. Get out of the way.
We got priorities here.
Yeah, I think
do have
Vanessa moved
priorities.
in next to me and then left also, like pretty quickly.
Did
She's like, this is a
Yes.
crappy location.
This is a bad
But hey, we had
location.
free
Yeah.
snacks, so
Great way to get interrupted in your work if you
Exactly.
you can pass
Excuse
if you
me.
can share.
So yeah, I mean, I noticed your LinkedIn reads, you know, principal data scientist, but I feel like architect still applies here. Really, I mean,
Yeah.
it sounds like you
Yeah.
were architecting solutions for the group, and as Sura was saying, and that's awesome. And now you are at a startup and head of machine learning. What has been the shift as you've taken on that role from previous ones? Now that you're kind of in that head role, for a startup versus, you know, big monster Intel or a Resilience, which is kind of a fast and furious, right? Would you describe it that
Yeah.
way, Sura? I think.
Yeah, for sure. But I think like, what I'd love is now that we have a machine learning expert like on board, it'd be nice to just kind of like explain what that is to, like if I were a 10-year-old, for example, because I don't know
Yeah.
that, we're all familiar with AI and the different things that we can do, but it'd be nice to get that intro before you get into what Mike was asking, which is also very interesting.
Oh yeah, sure. Yeah. So that was if I were explaining it to a 10-year-old, is that the question? Yeah. So
Because I have like a 12-year-old in house.
yeah, I'm a
So, I need
12-year-old.
to
Okay.
explain.
That's going to be Sura's reference, right?
I
It's gonna
basically
be
need to just
somewhere
answer.
plus or minus 2 years of her kid.
Yeah. So what I would tell her is that machine learning has been done for thousands of years, even before there was computers. We were the computers, because what we would do, and this is the whole point of data science, is we would take let's say if I were a farmer and I wanted to figure out the best time to plot crops, I might take the temperature each day, or I might say, I noticed that the sun comes up and is longer some days and not as long some other days. And so I just kind of keep track of those times, and all of a sudden I can start to predict sunrise and sunset. I have no idea of what astronomy is, or like motion and Newton and physics and anything like that.
Planetary alignments.
I'm just, planetary. I have no idea of any of that. I'm just literally just having these little data points and going, I bet you I can predict when the sun's going to come up. Oh, I can. I could bet you I can predict when the sun's going to go down. I can. That ends up being machine learning. We just have massive data sets now, and so we need computers to deal with the amount of massive data sets that we have. But all of that before, like the phases of the moon and the best time to plant crops and things like that, these are things that human beings have just done even before they learned what the actual underlying physics was behind it.
That's pretty cool. Cavemen were doing machine learning before we were, guys.
I was just going
100%,
to say,
100%.
I have an obscure reference. Maybe has anyone seen Castaway? Remember when Tom Hanks was in the cave and he was
Yeah.
marking things on the wall?
Yep.
That's exactly what I thought of when
Machine
you were
learning.
talking about that.
Exactly. He's doing machine learning.
It makes it so much more accessible because you hear about it and you're like, oh man, that sounds really difficult. I need so much math.
Channeling my
Exactly.
2,000-year-old man. I can, yeah, he was. It's true. Yeah, it's a fascinating way to look at it. When you put it like that, it really resonates. And I think it's the massive data set part. It's the the unachievable part for humans is the ability to look at tens of millions or hundreds of millions of things in such short order. And I was, I brought this up before on the podcast, and I'll just briefly mention it. But a friend of mine's daughter just got out of her master's program, and her thesis was on the use of AI to analyze cancer imaging.
Sure.
And the predictability of what they're able to look at, because AI can just see trends that no person can bring together in their head at one time. It has to be done within the machine, but the results speak for themselves, because they're like, we've got 90+% hit rate on being able to predict cancer further ahead than any human analysis.
Yep.
So the results speak for themselves, but that's really...
and you can go to the FDA maintains a website of cleared FDA AI algorithms, and they're
I will do
over
that.
Yeah, there are over 1,000 now that have been cleared. So they call it clearance rather than approval.
Yeah.
Because there's like approval means something like de novo and like it's from first principles type of a thing, whereas cleared is like it's a 510K, which just means like it's equivalent to something else that's already been approved.
Yeah.
But cleared algorithms been out there. They're already in the in the hospital today. When I was working in Intel, that was my primary role, was kind of working with the GE and the Siemens and the Philips and the Samsungs, kind of saying, okay, y'all are starting to incorporate these things into your MRIs and into the other things that you were doing. Let's try to see if we can do it as efficient as possible. They had stuff that was already in like little push cart, portable chest X-ray machines and AI that was already in there. So I think a lot of people are kind of amazed when they hear that like, oh, it's not like 5 years from now. It was like 8 years ago.
Wow.
Yeah. It's like now we're talking about it, but it was there. People were thinking about it.
Or it was like
there for
labeled,
It was, or it was like maybe it was labeled something different. I mean, a lot of people go, "Oh, what ML and AI," and I've even had people like it, and it's like ML's just like a subsection of AI, and there's always like people get caught up in definitions of things, and I think it's just okay. We're just trying to have a computer do something that A is important, and then B is something that hopefully a human being, it just helps a human being do. It's a task that a human being would normally do, but we're just trying to make it a little more easier for the human, a new tool to make it faster for the human being to do it.
It just took marketing a while to catch up.
Marketing loves that. Yeah,
Yes.
exactly.
Should be like a t-shirt.
Exactly.
Don't define me. I'm just
How do we
a
explain
machine.
this? Put this on the outside of the business, the customer facing side.
Exactly.
It kind of spins into our, the first segment that we outlined, and these are kind of loosely assembled segments, but I think it'd be a good opportunity to spin into looking at some of the terminology, right? And one question that comes to mind is, what is the fundamental role of ML in AI development? What is that, just for our listeners to kind of give some background on that?
Yeah, so that's a great one. So the machine learning part is really the part where you're building models, which are just really mathematical equations that the computer comes up with. They're not like you sit there and scribble the equation. And so ML, machine learning, is a subsection of that. That's like the farmer writing down the data and trying to figure out some equation that helps him to predict when the sun comes up. You're doing the same thing. It's just now it's an MRI and it's brain tumors, and you're trying to figure out where the brain tumor is and the thing. So that's part of kind of the field, and kind of the thing that with the architect, one of my roles is handling the massive amounts of data. So it ends up becoming really a data storage and data access issue more than the models. They do like the old 20 rule type of thing, that like 80% of the time you're actually trying to get good data that's easy to access, that's, has provenance, and, has all of this good infrastructure behind it so that it's easy to access. And then the 20% of the time is building a cool model that kind of works for something. So most of my time is worrying about, like, where did that data go? Are we trying to track that data? This is where like the LIMS systems come in, and all of the electronic notebooks and things like that are critical to make sure that you have some record of where your data came from and whether it's reliable.
So you really have to scrutinize how you ingest the data, where you're storing it, how much is being used to sort of build up the model, and
Yeah,
all that has to be, yeah. So it's
exactly. Yeah. And this is like looking at, like, we've done things where it's been terabytes of data per week. So that's a lot of data to kind of even
yeah.
imagine pushing it to like AWS, like the cloud service provider. It takes hours. And you're looking at, like, how can I get a faster connection? Do I need a dedicated line to AWS? Do I invest in infrastructure like here, like on site, so that I can have faster connections? Things like that. So it really becomes a data management problem that has a little bit of ML that's kind of attached to it. I don't want to dismiss it, but like that's really the architect role, is to figure out how to handle the scope of the work.
That's
Got
a
it.
little bit of the misconception around the AI architecture that I've encountered, right? Is you might have a lot of data out there, and we've talked about this in person with Azette and others, in terms of,
Yeah,
if you've got data that's not labeled and you can't access it and you don't know where it goes, it's just this data swamp that you're just swimming in and you can't get out of, right? So that's the first goal,
exactly.
is to organize it.
That's right, exactly. Yeah, and yeah, you're talking about is that he was always big into ontologies, and he was at the had the foresight to kind of go, let's try to set these systems up beforehand. And that was exactly right. It's really one of those things where maybe people coming out of college or people that first see it are thinking, I got this cool notebook. Well, the data that you're using in that notebook took a long time and a lot of love to get you that perfectly formed, thing that you unzip. And, it's not like that in the real world. You've just got data everywhere if you haven't thought through the problem of where is it going to go? How is it going to be discovered? How are we going to back it up? That sort of thing.
It's like movie versus reality. It just doesn't
It is movie
unzip into
versus reality.
beautiful things you can use. Yeah.
Yeah,
Exactly.
as somebody who's been in the robotics field their entire career, the number of truncations of reality I see in
Mm-hmm. Mm-hmm.
in movies
Mm-hmm.
about robots is without even getting the intelligent part into the play. But it's that's always fun. What do you find that most people don't understand about federated learning?
Oh, Federated. Yeah. So Federated is what I did my last part at Intel.
Yeah.
So first time I heard it, I thought, is it like using federal government
Yeah.
data or something like that? I was like, I
This
don't know
is
what they're
federal
talking
learning,
about. This
everybody.
is federal learning, everybody. But no, it's actually been a concept that's been around for a while, but Google really coined the term.
Yeah.
And so what they wanted to do was they wanted to have the models that, when you have your cell phone out and you're typing and it does the predictive text of what the next word is, those are machine learning models. That's AI that's helping you predict what that next word should be.
Accessible AI.
Yeah, you're literally using it every day,
Day.
whether you know it or not. That's what's happening. And they realized that they needed training data for that, and they could get training data, but they really wanted to see how it performed in the wild. They thought it, with good sense, that it would probably be really weird if they read your email messages, which they don't, or they read your text or whatever. So they said, well, instead of this traditional model of trying to take data and bring it to one place and trying to train a model on it, we actually send the copy of the model to like cell phones, and we have it trained on the cell phones on their data, and then we bring the model back. And so the
Huh.
data never actually has to go to Google. It's just Google's model gets transferred back and
Got
So
it.
forth.
my data is safe, but the
Your
model
data
has
your data's
learned
safe, but
something.
the model has learned something about your data,
Interesting.
and like whether or not you actually select the word, it knows whether or not the word that it predicted was the word. So it can actually, you're helping them label data at the same time, whether they know it or not. Every time
And
you
not getting a revenue
and
incentive at
not
all.
getting the revenue helping that at all. So, but yeah, so people started to take the idea, and at Intel we had the idea of using this. So it was a Intel Labs project that a group there had developed the technology. They had like the Hello World kind of, which is usually like the MNIST data set. It's usually like
Yeah.
handwritten, numbers and things like that. They wanted something that was a little more relevant. And I knew Spiros Backus at University of Pennsylvania. He's now at Indiana, and he was working in a group that was doing brain tumor segmentation. They had like a data set for that, and it was kind of like, usually I like the peanut butter and jelly kind of, or peanut butter and chocolate type of thing. You put your chocolate in my peanut butter. I like to bring those things together, and so I brought Spiros's kind of brain tumor segmentation stuff in to the Intel Labs Federated stuff, and we ended up coming up with this federation of hospitals. So we had 71
Okay.
hospitals worldwide, and they were all, I want to put in air quotes, sharing, but it's not sharing data, but they were sharing data to models. The models would come to them and they would train, and we were able to train a brain tumor segmentation model that way without ever having to like expose patient data. And it did better than any individual site. So if you were just relying on your own data, even if you had the best data in the world, you would get
It
a little
wouldn't
bit of a bump.
compare. Right.
It would get
Yeah,
a little bit of at least a
for
little bit of
sure.
a bump, and a little
Wow,
bit of
that's
bump is
awesome.
good. So yeah, yeah. So, and the nice thing about those, and this is where kind of the architect comes in again, is that if you've ever dealt with like healthcare systems, they're little fiefdoms. I mean, it's like biopharma. They're little
Oh, yeah.
fiefdoms. Like, like if you go to a Merck and you go to a Pfizer, like they're not going to play well together. They're just not. Like they're competitors, and it makes sense, But trying to find a system where you can have them all work together and have them feel like they're being protected, like their IP is protected, their privacy is protected, that sort of thing. So that's what we're also kind of thinking about ways of doing that, like the in the biopharma space of like, drug discovery, something like that, coming up with models that, like, one of the things that I was thinking about was like, how many negative experiments have we had? And nobody reports negative experiments. It would be interesting to have, like, there are all sorts of machine learning models that will predict, here's the structure of a molecule, a potential drug. Will this drug be toxic? Will it have a good absorption profile or something like that? Like some specific feature. And they usually use this as like the first pass is whether or not you want to actually spend, $10 billion with the research on
Hmm.
this molecule, right? Well, if you had a model that was trained in this way with the Federation, it could learn things about those negative cases that you don't want to share with anybody. You're not going to share like the stuff, but
Right.
the model could actually tell you, look, I can't tell, like, it's not going to tell you that somebody else had done this, but it will tell you that there was a bad result. I predict there's a bad result in this thing. And so the whole
Oh, that's
ecosystem is kind of
huge.
lifted up, right?
Yeah.
Without
How
anybody having
efficient,
to.
yeah.
Right, exactly. Like how much negative data is out there and how many companies have tried to recycle the same good idea that just doesn't work because the molecule looks great, but they keep doing the same molecule at different companies and not realizing it because they can't share the data.
Mm.
Yeah.
That's
And the
novel.
learning from your mistakes part, right? What you just mentioned is
Learning
like,
from
to
your
me, is
mistakes
like
is
the classic.
huge.
This is a lesson
Yeah,
that we teach children at a very young age. Is like, learn from your mistakes. Well, why don't we do that ourselves with these research projects and cut
100%.
down on all the wasted money used for, by the time something gets to automation, it's already a waste of time, but you don't know. You decided not to learn about it.
Exactly.
So
Exactly.
this is
Yeah.
something that was taken on as part of like this companies sort of for gain trying to go in this direction, but it sounds like there should be some incentive to create this like on a level where it's not really about making money but just feeding the model information that helps everyone really.
Yeah. Yeah. And that's what I mean. The organization. So there's an open source organization um, uh, called MedPerf, or sorry, uh,
Medical perfection, medperf.
yeah, medical. It's like a performance perf from ML Commons, the machine
Okay.
learning commons.
Okay.
We have like a subsection of ML Commons of ML perf and trying to do benchmarks. So we did one for the brain tumor one. Those were like a benchmark that everybody could kind of use, and we were trying to do the kind of the same thing. And so when I was at Resilience, that was actually one thing that I got Dwight to kind of give me the thumbs up that I could be on that subgroup kind of representing us to do that. It was just really AbbVie was the only one that kind of stepped up to the plate and said, "Oh yeah, we'll do that." But with just one, it doesn't really
It's not
work.
much of a federation.
It's not much of a federation, so they had the foresight to do it. But yeah, trying to get others to come in. But it is that fear of missing out that once you get one of those set up. So that's why it was so important for the hospitals that we might have had like 20 when we began, but like once people realized that, oh, we're going to miss out on this really cool stuff, everybody else took a look at it and said, okay, yeah, this actually works for our threat profile.
It's so
Gotcha.
interesting.
Yeah.
Very politics there, like lessons in politics. Get everybody to really want what you're doing by showing that like it's something they're missing out on. We can sell
Yeah.
this, right?
Another architect requirement. So try to get the politics architect into it as well.
Well, I imagine another architect role comes into play for you is like, studying and understanding the bottlenecks. What are what are the real bottlenecks in AI development, or what are the, I'm sure there's several, but at the like, what would be the number one bottleneck you see right now in terms of AI development?
Yeah, like in terms of AI development for biopharma, I'll kind of limit it to that
Yeah,
one.
sure.
But there are actually I found my hit of the week, so I'll share that at the end. But
Sweet.
Your
this is
pick of the
something.
week.
Pick of the week. Sorry, not a hit of the week. I'm still thinking of the biopharma space. It's a hit. It's a hit,
It's a
hit,
hit. We got a hit.
So I was at the NVIDIA conference last week, a developer conference, and they're really getting heavy into biopharma and drug development. And so there are all of these amazing models built off the same type of thing as like the transformer GPT kind of chat GPT kind of things. If you've heard of those, it's kind of their cousins kind of thing, but they're trained to take, if you've heard of like the AlphaFolds, those are these sorts of models, and they're trained to take a sequence, like a protein sequence, and from that single sequence, just a linear sequence, try to figure out how it folds and give you the three-dimensional structure. Well, that's great.
Man, that's
Right. I
awesome.
mean, that's great. And the way we would get ground truth is, you would do like a crystal kind
yeah.
of structure, or you would do a cryo EM, or you would do something like that. There is a lot of data on that, but there's just still not the amount of data that we need. The bottleneck, I think, in terms of the AI in this particular case, is just those experiments take a while, and like some things can't be crystallized, so you can spend all the time you want on it. And even if you get that snapshot, are you talking about the bound state of something? Like, you have an antibody connected to an antigen. Well, that 3D structure looks slightly different than if it's unbound. And then there are all these dynamics that just, taking a snapshot in time of what the three-dimensional structure of something looks like could be very different depending on what time you take that snapshot. And the models can't, well, currently the models don't take any of that into account. They're really looking at a snapshot in time. What will this be? So when I was at Resilience, one of the things that was the most frustrating to me was like, I was doing some of this with the team that was at Oakland. And we had really nice models that were predicting the three-dimensional structure, like of an antibody based off of the chain sequence, like the heavy chain sequence or something. But then we were trying to like see how it would actually bind to whatever it was supposed to be binding to. And I was trying all of these different computational methods, all these different models, even older models that were like built from the ground up, based off of physics engines and things like that. And I was like, these things really stink. I'm like, I must be doing like the worst job in the world of implementing these things, because my things are like, they just don't look right. Like maybe they're about a third of the time they look reasonably good bindings. And I was finally at a conference and where somebody was talking about it, and they were like, yeah, everything's crap. I was like, okay, good. It wasn't something that I was doing. It was this fact that like, these are not static things. They're squishy. Proteins are squishy. Antibodies are squishy.
Yeah.
So these pipelines are out there and they're amazing, but we really have a dearth of the data still, and we really need to start some of this dynamics in there as well.
Okay. I feel as you were describing that, it was resonating with what I remember from Heisenberg's uncertainty principle. It's like, well, things are moving, but you can't know. The more you know about one thing, the less you know about the other. And that's just the way it works.
Yeah. Yeah.
But it's not even that crystals don't like exist for some things, right? It's also that there's a lot of bad information out there. So you have to figure out how to make sure the model doesn't take that as an actual truth. And I think I've been at many companies where they start these crystals for weeks and weeks and months and barely get anything or nothing at all. And you're just, where do you go from there? Do you teach it how to simulate what it would look like and try to make guesses on that? Because that's not reality either.
Yeah, that's not really reality either. I mean, for things like that, I think it's just coming up with better experimental techniques. That the computer really is limited by what the human being says is the right answer. And if the human being is using the wrong answer, the computer isn't really going to come up with the right answer on its own. I was thinking of like when you were talking, I think when Sura, you were talking about kind of bad data, something like with the structure of DNA, Rosalind Franklin came by and she was the only one that could do a proper crystal structure of DNA and took she knew exactly the right way of doing it and getting the right images for Watson and Crick to go, oh, we understand what the 3D structure is. Everybody else was giving like skewed images. They were okay, but they weren't exactly right. And Franklin was the only one that like had like the right images. And once they had the right images, they were like, oh, this is easy now. We can put it together and we've got this Nobel Prize. But it was really based off, right, yes. Sorry for you. Sorry for you, but it's one of those things where it's garbage in, garbage out. If you have the wrong image, you just keep barking up the wrong tree.
Would you say that's it? There was another point we had here in our list, about looking at the future of AI scaling, beyond into bigger models. Would you say that's one of the biggest things that needs to happen, or people need to kind of focus more on what you put in to use in other words, can we use what we have better as a starting point to scaling things to be more effective and be bigger?
Can we recycle the garbage, basically?
Can we recycle the garbage? Yeah.
Use it more intelligently?
We can. I think maybe that's the right way of looking at it, is using it more intelligently. What I've seen, like especially at the conference, kind of reinforced this, was that they're starting to talk more about agents, like AI agents, and the concept of like taking Clippy, if you remember from Microsoft Office. Making Clippy actually worthwhile. So we have a subscription to ChatGPT and to GitHub Copilot, and it's been a life changer. Like when I'm doing coding, I'm not like relying on it to do the coding for me, but I'm having this conversation with this agent, which is really just a computer program.
Yeah.
And it's like having a second engineer in the room that doesn't get tired and doesn't get mad at me asking, what was that, rule for that again, or something like that. Tony, that, you should know that.
Tony,
okay,
you need
sorry,
You need to call OpenAI and
Yeah.
sell this idea, because I'd love a ChatGPT Clippy in my corner.
You could get the Clippy. Like I think that would be. I think that would be. Oh, that would be so retro to have like a Clippy that was
Wouldn't it be? It would
ChatGPT
be so
4 or something like that.
You need the sarcastic response algorithm built
Oh
into
yes, yes.
Tony, you dumbass. I told you this once
I told
before.
you that. How many times have I told you that?
Only
You're
you
definitely
wanted
writing
to
a
reword this
document. I told
email.
you.
Scoured the internet and nothing you said makes sense.
There's a whole
Where did you
group
get
of
your
folks going,
education?
what is this Clippy business?
We've aged ourselves on this show.
Clippy. Yeah, you won't find Clippy in Office 365.
That's right.
It asks you about clipping. It says, "Oh, I bet you want to play Minesweeper too."
Which you could never uninstall. So
Right.
But having another engineer in the room is good. I mean, you want to have,
yeah, exactly. Yeah. I mean, it really it's like pair programming or like having a second technician in the room. You end up going faster because you're talking the ideas out in your head anyway. So why not just write them down on the computer and see if there's some feedback? And if there's feedback, maybe it has a viewpoint, and I again put air quotes around viewpoint. It's learned things about how other people do things
For sure.
that maybe you've never seen before, and you're like, oh, tell me more about that. Oh, wow, that's interesting. That I hadn't come across that before. And you could be more creative.
There is a certain magic to getting that in real time, almost like you
Yes.
said, it's conversational. It's not from a person, but
Yes.
it's conversational, and it's why it's like a brainstorming session that can happen at any given time when you're using the tool. I think
That's right.
Yeah, I totally get that.
Yeah.
Super cool. What do you think, Sura? Should we get into the hot takes section? AI hot takes. Quick. So Sura titled this AI hot takes: what's overhyped and underrated.
Because I'm cool
Dun,
like
dun,
that.
dun.
I thought it was AI hot cakes, and I was like, oh, I'm
Hot-
hungry. I'm ready.
Hot cakes.
I'm ready for it. Let's bring it in. I have my
Snack
milkshake
time?
and my hot
It's
cakes.
only a matter of
and, you know,
time. Hot cakes, milkshakes, hot
And
takes, milkshakes. Oh yeah.
I'm totally gonna short you dancing. You know that, Mike.
There you go.
Somehow I knew that.
And for our watchers, they can't unsee that.
That's right.
on,
That's
Mike.
right. Yeah, they've been devastated.
Can't unsee that.
Whenever Mike is cute on our podcast, those shorts, just the views go crazy.
So, and all right.
That's a pretty good beatbox.
Settle down, settle down.
What's hyped and overrated?
This is when we went
Underrated.
off the rails.
We went off the rails, but what's the biggest overhyped AI trend right now? Just stands out like a sore thumb.
Jeez. Overhyped. I guess the whole thing is kind of overhyped.
Ah, there we go. I like
There
it.
it is.
I mean,
Yes.
yeah.
Whole thing.
And I think that's to kind of its detriment. And I think the one thing that's so like it gets frustrating for a while because like there are some people who are just adding like a little bit of some computer code to things and going, that's AI.
Mhm.
It's like, well, okay, but then there are some that like will look at, it did 6 fingers on a person and not 5. And I'm like, okay, but like, did you realize that it generated this amazing image of this
Yeah.
this person from
Forget about
like-
the extra
like-
teeth and fingers.
Forget about that. We can fix that. Like, but that's kind of what the hype has led to is like this idea of like, oh, there's going to be a super intelligence, and I'm like, that's great. But I'm just thinking about like, it actually can allow me to do things now that I couldn't do before. And beggars can't be choosers. Like, if I get something that's really decent, even if it's just a little bit off, I'm like, yeah, that's a pretty good. That's not bad. That help. That's helpful. So.
And
Yeah,
that goes with our previous guest where we mentioned, like, you still need humanity in this, right? Because we're the
Humanity.
experts at the end of the day that say, no, humans have 5 fingers, bro.
Exactly.
You know what I mean?
Exactly. Yeah.
What is
Yeah.
that?
Yeah. So,
Or 2 left feet. I love those ones.
It was like I think it was like I forget who it was, but I think it was maybe Yanukun or something like that was saying like, it's we're saying that these things have the intelligence of a 3-year-old and which is great, but then the 3-year-old's handing us this beautiful thing that they've colored, and we're like, you're out of the lines right there. Like, why did you pick red here? You should have picked you should have picked maroon there or something like that. And it's like, come on, guys, like literally, it's
lines
a
are
3-year-old.
too thick.
It's
Come
a
on.
3-year-old.
Yeah. So you pat it on the head and say, thank you. Now I'm going to take this.
Exactly. You're like, thank you. I'm going to take this and put this up on my fridge because it's beautiful. So.
Yeah, it's like, it's helping you write documents. It's helping you create things.
Yeah.
It's like an assistant. And we're sitting here saying, it's going to be a general intelligence. It'll be,
Yeah. Yeah.
No, it's cool. It actually helped me write this document,
Yeah.
and it was gonna take me 3 times longer because I was gonna bulk at these different sections. And it's
Get
like I
stuck
had
and have
advice along
coffee
the way.
and then come back later.
Yeah, right. Same thing with the self-driving thing too. I think back to that. It's like self-driving. It's like, you know what? You know how many cars didn't veer into other lanes because of just simple, basic analytical
stuff.
work being done on the
Stuff.
lines?
Yes.
And actually, some of them can do it now with very little paint marks on the road.
Yeah.
And because they're just using inertial stuff, and it's like, yeah, you're leaving the lane. I'm pretty sure. Okay,
Yeah.
and it figures that part out. And they're like, I mean, the number of like mitigations that are happening day to day, every single day you get on the road, it's like people are like, nah, I don't blow past that. It's like, oh, it's annoying. It's shaking my steering wheel. I'm like, yeah.
So David Conant, he got a Tesla that has the auto, or I think the auto drive or whatever turns on every now and then. Like they'll give you a free month or something. So Anson wanted to go to In-N-Out Burger or something like that one day, and so it's me and David and Anson and Martin in the car, and it does perfectly, like going right from the office to the In-N-Out perfectly. It's doing the lights, it's changing lanes, it's everywhere, and then it gets into the parking lot and it completely flips out, like it's trying to park, and it's like dude, and finally David has to grab the steering wheel and go, oh my God, turn it off. But it is like one of those things with a 3-year-old. It's like, it did this perfect job driving us there, and then I'm complaining because like the last 10 feet it can't do when a human being could like just 2 seconds do it. But that's part of the overhype as well.
First of all, ew that you didn't invite me to In-N-Out.
I know.
Second of all, that's a good that's a good example, because you did all the whole way. It worked perfectly, and then just didn't want to park. So
I've had a similar experience. Parking lots are just it implodes. Doesn't know what to do.
It does not know what to do at that point.
It's like the machine version of scanners. 2 cars are staring at each other. You're just waiting.
They just blow up.
Boom.
What is it though? Is it like too many lines or too many cars?
Too much input.
Too much input.
Return to factory. Yeah.
Wouldn't it be funny if it did that? Like In-N-Out's in sight and it just starts to go back.
Going back to the factory.
I'm calling a psychologist, not for you, for the car.
For the car.
Well, if you use a learning model, Tesla could say In-N-Out burgers are avoidance. Don't go to In-N-Out.
Don't go to In-N-Out burgers.
Put it in GPS. It says, I will not allow. What do you mean?
That's
Come
funny.
on.
At my local Chick-fil-A, they alternate. It starts out 2 lines, and it's, you go, you go, you go, you go. It all goes down to a single line. I love to see how a self-driving car deals with that.
Oh, my.
It's like,
Yeah.
What do you mean take turns? We don't take turns.
The thing I don't understand about Chick-fil-A is they've got like the input where you the little machine where you tell them your order, but then now they've got guys in front of it. So I drove up and the guy's asking me my order, and I'm like, but I can just speak into the speaker, and he's like, yeah, but that's what we do. And I'm like, but this is pointless. Like, why are you here? It's 100 degrees.
Exactly.
It's the human interaction.
That's true.
Yeah, but
My pleasure.
you don't understand, Jeff. That means I got to turn on. Like, speaking to someone through a mic, I don't have to be like happy, but speaking to a guy, be like, "Hi, how are you? Can I get?
Hey, thanks for coming."
Okay, so the problem is not the guy standing out there.
Okay.
It's you. Okay, I get it.
Sarah doesn't like to be happy.
No, it's
Wow.
like, you're at work all day and you're on. When you're on the drive home, you just want to get a freaking Chick-fil-A. Like, why you got to be on now?
Well, I mean, yeah, a bad choice if you need something in a hurry is always going to be a Chick-fil-A In-N-Out. And now this other one, this Cane's, Raising Cane's, that one.
Wait, there's one opening in
Yep.
Poway. I'm like, what?
I'm telling you guys, there's one down here in my town. It's just chicken strips. That's all it is. You order a sandwich, it's 2 chicken strips on a hamburger bun. That's it. Wow. Don't believe
and they're crushing
That's overhyped. There it is. That's
overhyped. That's right, Jeff. That's the
But their sauce is really good. I'll tell you that.
So this is a great lead-in to air.
Wait, I got a question though. Like you didn't mention what isn't getting enough hype in AI.
That's where I was
going.
What
isn't getting? Nice. Okay.
Did I cut you off, Mike? I thought you were going to the next segment.
No, it's good. That's good. We're a team.
High five.
Yeah.
The thing that has transformed my life in AI, the thing that doesn't get the most attention, are all of these note-taking things now. We have subscriptions to like we're in a meeting right now, right? It has this, we use this at our current company where I've never had to take a meeting note since I've been there. And it does like a Slack channel where it has like every single meeting that anybody's had. You can search through them. It gives this, it's an AI. It's not just a transcription, it's a summary. And it says like, here are the action items that were created, and it'll like alert people like whether you were in this meeting or not, you were assigned this action item.
You are voluntold.
Go back to this point in the meeting. You can see it at symbol. But I don't know about you, but I hate taking notes. I want to be in the meeting. I want to be just sitting there in the meeting and like listening to what's happening in the meeting rather than just doing this. The thing about that's really great is that same technology is now being used in healthcare clinics. So instead of the physician or the provider having to sit there and ask you, sir, can you tell me what brought you in today? And they're doing this, or they're scribbling in little notes. It's just a little microphone. It stays all within the hospital. And so the provider is just having this normal conversation, just like we're having. It's doing exactly the same thing that like the Zoom call did with this thing. And when the provider leaves, in the electronic medical record, there is a draft of a note. And it has like, they discussed this. Here's what the provider said. This is the follow-up, things like that. Provider just goes to the electronic medical record, reviews it, maybe edits it, and then stamps it. But like never has to have that personal, that Chick-fil-A, personal connection that Sura doesn't like. But now you've got it back.
But what's funny is I feel like doctors hide behind their input to the computer. Like I don't have that connection with them because they're like doing this, typing on the computer. So you don't have a connection with them, right? That and also if it can get the person who takes the appointment, the person who checks me in, the nurse and the doctor away from asking the same question over again.
Yes.
Of why I'm in. I'm like, my kid sprained her ankle. How many times do I have to explain to you?
Yes.
Just look that.
But there's a reason. There's a reason they're doing this. It's because they need to be able to check boxes in order to get paid through insurance. So my question to you, Tony, is you may not know, and that's okay.
Yeah.
But in that transcription, if you will, of that interview, boy, that sounded bad, but that interaction, my doctor interviewed me. In that interaction between your healthcare provider, did what they ask or what they say, when it goes through the AI algorithm, pick out, I can check this box, code so-and-so, code so-and-so. So now they can bill insurance for those services that have been provided. That's why they do it, sir. 100%.
Yeah, 100%. So those are called ICD-10 codes.
Interesting.
And so there are models that will do that. And so I believe, so Epic and Cerner are the 2 largest companies in the world, really, that do electronic medical records. And I believe they both have these sorts of AI models incorporated already into them.
Okay.
It is something where it's still not a solved problem, but that is, I mean, Jeff's exactly right. They're trying to get paid. And so if they can figure out like the right code to use, if they use the wrong code, they can really get in trouble.
Yeah. Yes.
Either they're underpaid or they're committing fraud. but they're also like always looking for like upcharges, like, okay, they did talk about that, so I can charge,
Yeah. Like,
There's a
I didn't
referral
talk
in here.
about, I didn't
They
come in for
did, it
this.
was in
They're like,
there.
yeah, but it's
Bingo.
the higher
You know,
box.
yeah.
We're going to charge that
Yeah.
because you
Yeah.
asked
So
We're
your
gonna
about it.
charge
daughter,
Yeah.
that.
yeah, your daughter came in for a sprained ankle. Does she have some cardiology problems? I thought I heard you
Exactly.
talk about that. Wait a minute. What?
Yeah, I didn't say that.
Well, it's funny. I mentioned that she did it dancing, and they were like, "Wait, let me check just to know." I was like, "Oh no, is dancing a different rate?" Like,
Not yet.
Depends on the kind of
but it will
dancing you're
be.
talking about.
Skateboarding. Let's see. We'll call
that
that
would be me last week.
bicycling. Yeah, I think my doctor actually was using something like that. Now, I didn't really know it was behind the scenes, but asked permission. Can we use this during your
100%. Yeah.
your GP, your annual physical? And I have to say, the amount of engagement and not doing click, that was nice, because we're just having a conversation the entire time, and it took I don't know, maybe an hour or so for the final thing to hit my record on. And I think they use Epic too. I think that's their
That's
their
really
service.
cool.
But
Yeah.
they just.
'Cause I want to talk to my doctor again, not like be just another number that gets ignored while they're
Plus,
typing.
it's getting harder and harder to get appointments with these people, especially him. It's like 6 weeks in general. Like any given day, you want to make an appointment, it's going to be at least 6 weeks out. I'm like, that's just crazy.
Yeah. Yeah.
Can't get
Absolutely.
celebrity doctors, Mike. I don't know what to tell you.
I don't know. I need to stop going to LA for my doctor. And is that something that you see in Canada? Because we've got 4 people on the podcast right now that are in the U.S., which we have our kind of laws and privacy. I mean, is that something?
I was going to say, no, here we don't get that.
They don't do that. That's
No,
kind of the
and the
traditional approach.
consultation is typically one issue and that's it. You cannot bring up the whole thing.
Interesting.
So it is, it's a whole different thing here. Yeah,
Do they
I have
talk
never
about that
seen...
kind of thing, using more of that in healthcare?
Not really. I haven't heard anybody having a conversation about that.
Okay.
I guess that is in the US because you have private healthcare. But
Yeah,
here,
it's the public healthcare versus private healthcare approach. Right?
It makes sense because you want to ensure that you provide the right records to the insurance. But here we have public insurance. I mean, it's all Ontario insurance for us.
Can I ask a question? Because sometimes even if you have like public school, people take their kids to private school. So do you have like also private like health insurance? I know this might be totally naive. I apologize, whoever's listening.
No, we don't right now. We don't have privatized healthcare here.
So even if you wanted, you couldn't get like a private doctor.
Yeah, no. Many people go to the US in desperate cases where they need treatments. They go to the US for that.
So those folks out there saying, "Oh, Canada, free healthcare," people actually come back over the border,
right?
As saying, I mean, it's the same thing. I know it's happening in Germany because I had several colleagues at my previous company they had private insurance in Germany, right? I mean, some of those systems are starting to change enough to where people, if they can do it, will go to a private healthcare approach. But very interesting. I like that one. Yeah, because that's it's not something folks are talking about a lot. But
yeah.
Okay, now here's the big one. Your big bold AI prediction.
Oh, I when I read the thing, I was thinking about this, and it's been my prediction forever, basically, is that we cannot predict it.
Boom.
And it's unpredictable. And this is why I say that is that I've always said that, like, so my grandmother was born in 1919, right? She's deceased. But when in her lifetime, from 1990 to when she died, we had like penicillin came online. We had, improved anesthesias. We had the MRI wasn't even a blink in anybody's mind, ultrasound devices, things like that. If you had just taken like the linear progression of the field, it's almost like, I think it was like Henry Ford said, if we'd asked people like what they wanted, they would have said a faster horse, because they didn't know that there was an automobile that was possible. So if you try to predict from just the current linear thinking of, well, it's just going to be an extension of ChatGPT, I don't even think people saw ChatGPT until it actually was there, right? Things just happen in amazing spurts. And I really do believe that like since about 2012, I actually wrote a blog on it with CRISPR, the resurgence of AI, all of those started around 2012. And I think like maybe in 2050 we'll look back and say like in this half century or this half century that this has almost been the start of a new enlightenment or a new renaissance, because we're in one of those periods where it's just radical. They're just things don't go linear anymore. They go exponential.
I've been calling it the AI revolution.
Okay.
That would take on different connotations. AI, revolution.
And revolution.
That's kind of different because if the AI has its own revolution, we wouldn't be here.
Yes.
Yeah, I was about to go into a joke that was made about when Rush was on an interview. The band Rush, they're like,
love the band.
Here we go.
I didn't even know who Rush was until these guys.
When you were listening to your own song, was it so epic that you were influenced to write your next song based on your song?
Hey, there's a song about that from Rush called Body Electric and talks about a humanoid escapee trying to save itself. Mike knows exactly what I'm talking about. Body Electric.
It was nerdy. It's nerdy stuff. That's for sure. No question.
I'm going to play a riff from that in the episode when it airs.
Body Electric. So let's head into the future.
Yeah.
Besides bold predictions, super,
yeah.
Mega predictions. But I mean, for the next 3 years, 2 years, 3 years, and well, in this space, sometimes people are like, what are you talking about? 2 years? We're talking about 2 months,
2 months, yeah, exactly.
But however you want to scale it, don't take my suggestions as far as the scale on which to put these things. But what is the next big innovation in AI architecture?
The one that at least at the keynote that Jensen did, who's the head of NVIDIA, his last thing was talking about they actually open sourced something called Isaac, and it's for robotics. So it's like a whole robotics ecosystem software. He's talking about these agents having embodiments as well. Now you worry about like, oh, that's Terminator type of stuff, but like if you think about it, if they're just doing like one thing, that's also where you get into some of the more interesting learnings that if they now have arms and legs, that they have now reinforcement learning that they can do. They can learn like a human child could learn because they literally can interact with their environment. And so those are the things where I think, and again, it's one of those things where it's hard to predict like what we'll learn from that or what they'll learn from that. But I think that you'll start to see these things where they won't be just the cute robots that kind of just do, that sort of thing anymore. They'll actually be pretty helpful robots. They might only do one thing, but they'll be pretty helpful at doing that one thing.
This is NVIDIA's Isaac, right?
NVIDIA's Isaac, yeah.
NVIDIA's, yeah.
Yeah, NVIDIA's
and they've
Isaac.
actually got something that they're selling, or not selling, they're calling it like now available, like fully customizable model that they've already kind of launched, right?
Exactly. They're trying to be like the whole ecosystem kind of in one thing. So it's a really good strategy. I mean, not just the hardware, but like showing people exactly how to do the software, and even coming up with like
open source ecosystem.
All of their stuff is open source, which is great. And it's like it's open source in a way that it's also commercially friendly. Like sometimes open source means something different than what you might think it means. Like if you're trying to use it for a company, that might be a problem with some open source licenses. But their stuff is like, yeah, anybody could take this. You could make it into your own company. You can make as much money as you want off of it. And we're just happy that you're buying our chips. And that's all we really want out of you. So it's a great strategy. And yeah, and they already have like basic models that you can go out
like
and play with.
The article about the Groot N1
Groot,
shows it's basically like every, I won't say everybody, it clicked with me because it shows like a mom in the kitchen, and I don't know how many times I've been like, oh, I just need another pair of hands to do this, So they're definitely marketing it a certain way.
Yeah, I think that'll be the Groot, like, is their little humanoid robot type of thing that you'll be able to just buy with this Isaac system and then program. I was thinking about, like, Mike was talking about the 80s, and I think everybody's got Rush, so that's good. Imagine if we had this stuff when we were growing up, like how much smarter we would be. I mean, to have this, like we didn't have the internet, we didn't have cell phones.
Yeah.
We would go down to Radio Shack and
Radio Shack.
that was it. Radio Shack
TTL
was
circuitry.
was it.
Typing my
That's it. I
reports
was like,
on a
my
typewriter and
God,
putting them in a little laminate
I know.
thing.
Radio Shack
Tony,
was it. So yeah.
Tony, we had AI, but it was a limited data set.
What it was. Yeah. That's exactly what it was.
Welcome to
cool
Speak and Spell.
Spell Apple.
I talked about it was in 90, I think it was 96 or 97 that Jan LeCun had the MNIST data set came from this postal service thing. And at the time, he was using a convolutional neural network to solve it. And so he won the contest, it became a big thing. That whole thing can be done in like 20 lines of code now.
Wow.
By somebody probably in middle school in Python. It's very, very quick. That what was an entire research field that was a contest and a lot of money, into it, is like a quick exercise. It's like a homework assignment.
But I mean, do you remember like coding on all these new, things that came out? Like I had the first Apple, 3E, and I was like doing like coding, and my daughter comes home from school, 4th grade, and she's like, "Yeah, I just created this mobile game. It's so boring." I was like, "Bro,
yeah,
if only
you don't.
Yeah.
If you only you don't.
an afternoon in class.
Yeah. I remember Commodore VIC 20, which had K of RAM, K, not 20 megs, 20K of RAM. And then they had like for graphics, it was, they called them sprites, which I think were pixels at the time or something.
Remember that? Sprites.
And you had to poke and peek a sprite. And
assembly language.
It was much more complex than what you can, now you can just drop a character and it'll code it for you. And it's like, if that were around when we were growing up, I would have been in heaven.
I bring this up, and we're not educators here, but we are sort of.
Yeah.
How do you make the kids get engaged? I mean, you talked about a lot of complex things here.
Yeah.
How do you engage the kids in that?
Break it down, Tony.
If you know, I'd be a better person if you could tell me, even with my own kids. But I heard something once that I thought was really interesting about that, is that like they might be training for a job that doesn't exist yet. And so, they might be sitting there and doing something that you're like, that is just a complete waste of time. But it's something that they see as a passion, and it's something that probably other people see as a passion. And maybe it's one of those things where linearly we couldn't see that jump, right? Mm-hmm. But those kids that were playing video games in the 80s, they made the jump in the 90s to go to college and started putting computers on everything, and they made the jump in the 2000s to start the internet on things, and eventually that kind of got the ball rolling. So I think with the engagement, it's really you can't force it. You can lead a horse to water. You can't push his head into the water and hold him underneath it until it actually,
especially a horse. No, I would not recommend it.
Can't lead. Yeah.
But hopefully they'll find something that even if you don't realize it at the time, they're training for they're training for a career that doesn't exist yet.
I love that. Like, just be supportive of their passions. Because I think, Mike and I talk about like being interested in all this stuff when we were younger, and now we're like programming and playing and building robots,
Yeah, exactly.
Mom, Atari came in handy.
Yeah. I was like, all it was I had a Commodore 64, and my friend had a way of getting games, and I'm like, yeah, let's do it, and I was forced to learn computers because of that, and I didn't really care about learning computers other than the fact that I could play video games off of them.
And I think we have to recognize the different perspective that younger people have that we will never have as older people, because it's sort of like in robotics, we use this term called the boxcar filter, right? It's just it's a filter. Imagine it's just this filter that's cruising over trajectory, right? Trying to smooth things out or predict, it's also got a little bit of a predictive element because you're trying to, take the harsh, real time encoder count by encoder count input and turn that into something that is going to look smooth and ignoring noise and all that stuff. Anyway, it all resorts. But as the older you get, your boxcar gets longer, so you're including more older data, and more of that older data as you're applying it to newer data. Well, it's going to be applied. Whereas when you're young, your boxcar is nice and tight, and you can use that. You don't have all those things. And I really see that in like see even just my niece and nephew growing up, especially my nephew, who he's just his view of the world and his view of where to put his time. My first instinctive response is like,
what a waste of time.
But then I start thinking about it more. I'm like trying to block out the past, don't think about the past. And I start seeing it's like, some of the things he's working on as a mathematician. Again, a mathematician's role, and when we were in school or when we got out of school, is one thing. A mathematician's role today is very different. A lot of it has to do with a lot of this AI and data science that just didn't exist back then. Yeah. So really,
I love that
really
analogy, Mike. First, I thought you were going to go into the trolley car problem, but I love this analogy much better.
The boxcar, yeah, good old boxcar. I'm actually super excited about kind of what the next generation does with a lot of these things as they, because they're coming out of college, and this is like the talk of the talk, right? This is what's happening. Where are they going to go with it, and where are these different career paths that we knew of going to take folks in the future? I hope universities, I'm sure they're a little nervous too. They're like, what about this department? What about these programs? What's going to be the popular one? And on that note, do you have any career advice right now? If you were to talk with somebody that's kind of up and coming, what you would tell them?
Yeah, I do this a lot, and mostly it's if you are trying to get a job with me and you don't have like a GitHub page where you're showing your work, like, and it goes back to that point that I said about you now have the tools so readily available now that if you're waiting to be told to learn something or waiting for something, you're already behind. Like, so get out there. Like when I talk to people, I'm like, oh, I'm really interested about your field. Okay, well, what have you done in my field? Oh, well, I haven't been in your field yet. I'm like, my field is accessible through open source tools. Like there are so many GitHub repos that you can go through and just start copying stuff and then start expanding on stuff and start, trying to understand how things work. If you do that, then you come to me and show me that I do have passion in what I'm doing. If you're just saying, oh, I'm passionate about that, well, why aren't you doing it? There's nothing holding you back at this point. All of that is available.
Got it. That's great advice. Yeah. I mean, come into it with all the tools. Yeah. Like the things you can learn. I went and learned some tax accounting stuff just from online, right? I mean, if you want to learn something, it's pretty much out there.
You can go to YouTube. Yeah.
Sura pretty much uses these facilities all the time, I think.
Yeah.
She's always learning something. So
it's also like, hashtag don't bullshit Tony.
Don't bullshit Tony.
Exactly. Show me.
That sounds great. Show me what you got.
Yeah. Show me what you got. Yeah. It's like, oh, you're passionate about it. Great. What have you done yet? Nothing. Okay. Well, what are you waiting for? So there are 3D printers out there. There are YouTube videos on how to do things. There's quick courses that you can take. There's free courses you can take. So just
and we see that a lot from our colleagues, who got like laid off or who have been job hunting.
Yeah.
They're still building things and on forums. Eli Fine, who was on our show. Yeah. Built, a total tool for people, open source, just because he had the time. Like that's what passionate people do.
That's right. That's exactly right. Yeah. Yeah. Eli's a perfect example of that. Yeah. You couldn't keep him from not inventing something new.
Just put that at the top of the resume. Yeah, that's what you had to do. That's the top of the resume. What's with all this other stuff?
Eli fine. You can't keep him from doing stuff.
Also, Tony.
And did he, no, when Eli did it, did he do it on the treadmill?
Yeah, yes.
Only after Sura pointed it out.
Okay. All right. Okay, good.
I do the shorts, it's hard, and he just was like, what?
So what I'm doing now?
Like I gotta have something to compete with that. I need a trampoline or something. What's your one key takeaway for our listeners?
Start now. If you really are interested in it, the things are there for you. Don't wait if that's really what you want to do. Particularly if you can find something that aligns with, I don't care if you like manga comics or something like that, find a ChatGPT that does manga comics and start to learn how to make that. You can find a way to take one of your passions and connect it to this. It doesn't have to be like biopharma, it could be something very, very simple. But yeah, it's there. It's like, what are you waiting for at that point?
Take your opportunity, folks.
Take the opportunity.
Let's do it.
It's
Go
there.
for it.
Yeah, exactly. And the nice thing about it is that, like, if you fail, you fail. That's the whole point. I mean, that's how you train a robot. It fails many, many times, and eventually you get it right. Yep. That's how you learn.
Fail as many times as possible.
Fail as many times as possible, and yeah.
Well, when the time comes, I'm super excited to hear more about what's happening at your current company, and as you continue to grow and become more public about what you're doing. And we will now roll into our the pick of the week segment with our guest, Tony Reina. You're first up.
Unless you need a moment to look around.
Well, the one that I was thinking of is, I've got it up on my thing, but I can give it to you for like maybe you can put it like in the chat or whatever, the link.
Yeah, we'll put it in there.
But there's one of the preeminent websites which is really weird in AI. Is called Hugging Face. Hugging like and then face. It is the strange, like, I think it's just a joke.
Well, there it is.
Like,
look at
like
that.
the Hugging Face. It is like, this is where I'm saying, like, go out and try stuff. They have all the AI models on there. If you go to one that is called Protein MPNN, so protein and then Mike, Papa, November, Protein MPNN, they actually have a nice dashboard, and it is a dashboard that will allow you to take any protein. So if you can upload the PDB structure, or you can give it the, there's usually like a 4-letter digit kind of assignment, what it is. And you're able to, what the model does is, how I was talking about AlphaFold, that the AlphaFold model will take like the primary sequence, the sequence of letters that are the amino acids in the protein, and AlphaFold takes it and makes it into a 3D structure, right? What Protein MPNN does, this is the same thing that this was actually created by David Baker, who's the one that won the Nobel Prize this past year. Protein MPNN does the reverse of that. And so what they're trying to do is they're looking at, if I take like an existing antibody, let's say, fold it into the 3D, and now ask what other sequences would also fold into that structure. And often structure goes along with function. So this is how people design new things, is they're actually looking for variations of the primary sequence that still seem to fold into about the same sequence. And this Protein MPNN site, this actual thing, will allow you to do that, and you can even like run AlphaFold on it. It has an AlphaFold thing on it. It's a really cool website. I think it was Simon Dwyer who does a lot of that. But Hugging Face has all sorts of things like that. You can kind of go to town and play with your favorite model.
That's amazing. One of my favorite mentors from my days at GenEncore was David Estelle, and he always talked about these amazing things you could do with proteins and how they fold and all their. Yeah, I'm sure he would love something like this.
Yeah, absolutely. Yeah, you can just, even if it's just to spin the 3D molecule and zoom in and zoom out and things like that, at least it gets your mind going and thinking, hey, maybe I want to learn more about exactly what this model does and how I can code it myself.
Very cool. I'm not going anymore based on that, because that was just way too intelligent for what I was going to show.
Wait a minute, you actually had a pick and you're going to bail on it?
It just doesn't match up to what Huggy Face just...
The Huggy Face.
Picks of the week can be a broad range. Thank you for that, Tony. We will put that in our show notes when we release the episode. Jeff, you want to go next, or you have one?
I would love to, but I don't have anything. I'm sorry.
Aw.
All right. Well, mine's going to be on coming out from a different direction. I am in the customer facing business development side in my day to day, and I was due to order some more business cards recently. I'm thinking, you know what? I didn't even use the short stack that I had that fast. I find that I'm using them less and less, but there are certain times when you do want to make sure you get that, for certain, assured, even reminded exchange of information. So the reminded part is what kind of got me thinking, a business card, you give it to somebody, but I mean, I do the same thing. It goes into a file. I'm going to go review them later. Later becomes much later, epically later. Never later, something like that. It's just progression. So I'm just, all full reality. So I have decided I'm trying this out. It's called the dot card, and dot card. That's not confusing. dot cards. It seems like you can get just about any subdomain, and these folks are leveraging that full force. They've got dot cards, dot profile, and all these things are essentially different sites. So if you want to buy the card, you go to dot cards. This one's actually metal, and it has a QR code on the back. And so there's two ways to exchange the information. I can just provide the QR code or just tap it to any NFC compatible phone. It will pull up the link, and it gives you right away the options, gives you all my information, but it also gives you right away, do you want to add this to your contacts now? Boom, done. So, remind me that I collected this card, right? It also has these functionalities, so you can go, oh yeah, that's right, I talked to Mike at the trade show. But shows like SLAS are famous for, too much bandwidth needed for what bandwidth you have. And these are the things that take the back seat. So anyway, dot cards. It gets, I would say, it's like 4 out of 5 review. I mean, there are other versions of this technology that exist. No data is actually stored in this card. So what I've done is I bought an NFC chip that has a unique identifier, but that's okay because the idea is just to have that transactional thing, and you can change your profile. You can have a profile for work. You can have another card and say, this is the one I'm going to use at Comic-Con when I want to give my other deets out. This is my Helical Brew deets. Whatever. I got my deets. I got all the deets in my cards. I can have deets for everything. But dot card if anyone's interested. And I would get the metal one because their normal card gets pretty bad reviews. And I don't know. I've seen it's like plastic and it looks like it gets chewed up pretty good and it's not going to last very long.
I'm glad you have one of those. JSAT exclusively has dot cards, and you can just scan the QR code and it actually will pull up the person's LinkedIn. You just follow them and connect right away.
Well, and that's the thing is if you want, you can actually prioritize. That's right. So if you have something that's link capable where you can go straight from the QR, you can actually exchange the information, but also go straight to somebody's profile and have that programmed in the card when they do it.
So cool. Yeah, there was some conferences I couldn't attend, and my team took my dot card, and the people were just scanning my QR code.
Getting a whole bunch of new friends you didn't realize you had, right?
I love when people add you to LinkedIn without a message. I'm like, I don't know who you are.
I think the modern, very few people ask me for a business card. And when they do, it's like they don't really want the business card. They just want to be able to contact me and follow up.
Direct.
And, it also gives me the opportunity, if they set up a dot profile, we can exchange immediately. But that's, the odds of that are still pretty low these days. But like I guess Sura and I mean, if you pulled me up on yours, I would see your,
we can finally connect, Mike.
The automatic connect. We've never been connected this whole time. We're always completely well, fantastic. Thanks so much, Tony, for coming on. It was a really interesting discussion, and like I said, looking forward to hearing more about what you're doing and following along there. But such great advice, especially for those folks out there looking to get into all things AI and kind of maybe even working where Tony is. Who knows, right? And any plugs you want to give before we go?
Shameless plugs.
Shameless plug.
I'll give a plug to my kids, CJ and Peter.
All right.
And my wife, Bryn, who is in the next room right now recovering from the flu that I just got over. So I'm going to be taking care of her for the rest of the weekend.
I caught a little something while I was in San Diego, too. Something's going around anyway, I think, in general.
Something's going around.
It wasn't me.
Yeah. I was just there. No. It started before. Yeah, it was like when I first got there, I went out. We had the LRIG conference or LRIG meeting there in North San Diego, and yeah, something was going around in that room. There's something going on there. But oh yeah, and I guess it's worth saying we do have the new Helical Brew swag, right? We're
wow.
just for the viewers,
nice.
that not that we haven't talked about that at all, but
once we get sponsorship, we'll offer them to our guests, Tony.
That's right. Yeah, I'm not saying that we've got a store for it, but we are getting into swag land a little bit.
I heard, Elizabeth, you wore yours because Boston was cold as heck.
Boston was cold as usual.
So helpful. Oh my goodness. I'm like, yeah, this is perfect. Well, I have it in my pocket with me all the time now, even here in Canada. It was so cold when I arrived.
It's the perfect type of beanie for something like that. It's just it's good, excellent choice, Sir, on the beanies. Yeah. And with that, we're going to wrap up this episode of the Helical Brew. Thank you, everyone, for joining us. And for more information, as always, you can go to www.helicalbrew.com to see us on our YouTube channel. And of course, we're going to be forever on Spotify and iTunes podcasts, where you can get the automatic download there. Until next time, this is the Helical Brew Crew with Tony Reina saying Have a great week, and we'll see you next time.
Thank you.
Thank you.
Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.